Okay, one last example of a linear differential equation that I want to do is let's solve y prime plus y equals x, given the initial value, the initial condition that y of 0 is 3. Okay, so this is an initial value problem that basically means that we'll proceed like we did before, except we'll be able to figure out what this constant c is equal to. And so the way that we did this before is we have to multiply both sides by an integrating factor, which is going to be, let's see, the coefficient of y prime is already 1, so we don't have to worry about that. We're just going to take that quantity, which is also a 1, and we're going to integrate it and then exponentiate that integral. And so it turns out that our integrating factor will be e to the x. So that tells us that our differential equation is going to be e to the x y prime plus e to the x times y equals x times e to the x. And then at this point, we can recognize the left-hand side of the equation as the derivative of a product. So that means that this is the derivative of, let's see, in this case, y e to the x. The right side remains unchanged. Integrate both sides. The only thing now is that the integral of the right side is going to be a integration by parts integral. So we just have to remember how that works. So I hate memorizing formulas. So if I know that I can just get to a formula within 1 or 2 steps, we'll do it. So f times g, if you just remember the product rule, and then integrate both sides, and then that gives you f times g. So that tells you that, for example, the integral of f prime times g is equal to fg minus integral of g prime f. Okay, so that's how I remember the integration by parts formula, is rather than just memorizing. I know how the product rule works, and I know that if you differentiate an integral or integrate a derivative rather, you get back the original function. So that's how this is going to work. And so let's see, what's the thing that we want to integrate? What's the thing that we want to differentiate? Of course, the thing that we want to integrate is e to the x, and then we want to differentiate x so that the powers of x come down. So let's see, we're going to have our f prime is going to be e to the x, and then our g is going to be x, which means that our f is going to be also e to the x, because the derivative of e to the x is itself, and g prime is what? The g prime is 1, of course. And so this is going to be the integral of f times g minus the integral of g prime, so 1 times e to the x. And so this all works out to x e to the x minus e to the x plus c when we integrate. All right. And so this tells us that our equation y, if we take, so remember that, let me just fill this in a little bit. These are all expressions for y times e to the x, so that means that y is equal to x minus 1 plus c over e to the x. And then we had our initial value that y of 0 was 3. And that means that if we plug in y of 0, so in other words, when x is 0, y is 3. So 3 is y of 0 on the one hand. And then on the other hand, if we plug in 0 for x, we're going to end up with 0 minus 1 plus c over e to the 0. So that means that c is going to be 4. And therefore, our solution is going to be y is x minus 1 plus 4 over e to the x. So that's our one and only solution to the initial value problem.